Okay, good afternoon. So let us start today's lesson. It is a very simple but very important lesson. So we will finish this lesson today, angles in the circle. So you already know what a circle is. There are some terminologies. Of course, I don't know the Swedish words. I want you to learn them yourself if you want to, but the English words I can mention it here for you. So if I have a circle, then you have the center. For example, let me call it a C or O, for example. And then you know that there are a radius to a circle. Yes. So for example, let me denote it by R. And you know that it doesn't matter which point on the circle I choose. If I connect it to the center, the length is the same as the previous one. For example, if I take this point and connect it here, if I have a circle indeed, then this length is also equal to R. The same here. All of them are R. Okay, so that's the radius. What is the diameter? Yeah, so the diameter is a line that passes through the center and cuts the circle at 2 points. So this blue line segment that you see is an example of a diameter. If I ask you what the length of the diameter is, then of course it is clear, it is 2 times the radius. Okay, another terminology that I want you to know is that if I have one piece of a circle separated, this one is called an arc. Yes? So a piece of a circle is called an arc. The biggest arc is what? The biggest arc is the circle itself. Yes, so that's the biggest possible arc. But you can have smaller arcs. That is something that I want you to know. And then if you connect this one, if you have an arc and then you take these points and connect it to the center, you get one piece of your circle. That piece is called a sector. Okay, so I just want you to know what are these words. So if you have something like a piece of an apple pie or piece of pizza, that is called a sector. And there is another terminology that I want you to know, and that is arc length. So what do we mean by arc length? So let us say that this is an arc, and if I want to denote it, usually I denote it by AB, but then I put a something curved on top to show that I am talking about an arc, not a line segment. Because if I have 2 points on the circle, I can connect them along the circle itself, it becomes an arc, or I can connect them as line segments through within the circle. That is not an arc anymore, but there is also a name for it. This blue one is now called a chord. Okay? So, and then you see that the chord corresponding to these 2 points seems to be shorter than the arc. Yes? And then what do we mean by arc length? It means, if you want to imagine what do we mean by arc length, it means that you can imagine an ant moving on the circle. The distance that that insect ant is moving on this arc is called the arc length. Yes? Okay, so what is arc length? I told you that, for example, if you can assume an ant is moving on the circle, and then that ant moves from here to here, the distance traveled by that ant is called the arc length. In other words, you can imagine it in a different way. So let us have a piece of a string. I put one tip of the string here, and then I bend the string in a way that it completely overlaps with this arc. And when I reach here, I cut the string. Then I will have a I will have a bend or curved string. Then I make it taut and stretched. When it is stretched, I measure it with the ruler. The length that I get is called the arc length. Yes? Is that clear? So the arc length, you can imagine it as the distance traveled by that ant, or you can imagine that you have a piece of thread and then you put it here and then stretch it, and then measure the length. That length is called the arc length. Yeah, so these are very simple words I want you to learn. So arc, sector, arc length, chord, and center, radius, and diameter. This is more or less the same thing that you already knew, but the interesting thing that we want to learn today is about angles in a circle. There are two types of angles. We discuss about them within a circle. One angle is called a central angle. Central angles, I have to tell you what they mean. We also have another type of angles. That lesson today is about those two angles, inscribed angles. Yes? Okay, so let me tell you what is a central angle. Let me tell you what is an inscribed angle. They are very simple concepts. So if I have a circle, every circle has a center. So let me call this C. If I connect this center to 2 points of my circle, this one and that one, it makes an angle. That angle is called a central angle. So if someone asks you what is the meaning of a central angle, you say that it is an angle whose vertex is the center and its arms are the radii of the circle. Is that right? So this alpha, if I call it, it's a central angle. And if this one is A and this one is B, we can say that this arc is subtended by the central angle alpha, yes, or alpha subtends arc AB. It's the terminology. You can say, I mean, this is an English word for saying just an arc opposite to alpha. If you don't like this word, that's exactly the same meaning. So every central angle is a central angle is an angle whose vertex is the center, and the arms of the angle are the radii of that circle. So in that regard, alpha is a central angle. But there is another central angle with the same center and with the same arms. What is the other central angle? This angle. Yes? This angle, which I call it beta, that is also a central angle with the same vertex, with the same arms, but look it from the other direction. So I have two central angles here. One of them is alpha, one of them is beta. But the difference is that alpha subtends which arc? The smaller blue arc. But beta subtends the bigger black one. Yes? I can say the bigger black arc is opposite to beta. This smaller blue arc is opposite to alpha. But they usually, in English, they don't use the word opposite, even though that's completely acceptable and understandable. They use the word subtended. Okay? That's it. This is the central angle. Any questions? For example, do you think that if I draw a diameter, I can have a central angle? What? Let us try understand it. So if I have a center and I draw a diameter, any random diameter that you like, okay? Do you see that I have a central angle? Actually, I have two central angles here again. What are they? What are the sizes of those central angles before me telling you? 180, yes? Because this is one central angle. Is this a central angle? Yes. Because the vertex is the center and the arms are radii of the circle. So that is a central angle. But this is one particular central angle that you already know the size of it. What is the size? 180 degrees. And what is the other one? It's also 180 degrees in this case. So can you tell me what is the biggest size for a central angle? 360 degrees, the whole circle. Yes? So these are very simple ideas. But what is the meaning of an inscribed angle? That's also a very simple idea. So an inscribed angle, when I want to talk about an angle, I need to tell you where the vertex is and what the arms are. The vertex is no longer the center. The vertex is somewhere on the circle. So So I will come to your question. So for example here, I choose this one. And the arms are not radii. The arms are chords. Okay, so what do I mean by that? For example, this one, this blue line, I gave it a name to you. What was the name? The name was a chord. And then I can draw another chord. Yes? So you see the vertex is on the circle and the arms of the angle are not radii, they are chords. And then they will give me an angle between them. That angle alpha is called an inscribed angle. Yes? And then if I ask you, what can I say about this arc? Again, you say this, you use the same word. You say that the arc AB is the arc subtended by alpha, or alpha subtends this arc. That's the notion of an inscribed angle. So the difference, if you want to repeat, in a central angle, the vertex is always the one, it's the center, and the arms are radii. But when we talk about an inscribed angle, then what should we say? We say that the vertex should be somewhere on the circle, and then the arms are chords. Here, if I ask you how many central angles you can imagine, infinitely many. How many inscribed angles you can imagine? How many? Infinitely many. For example, the other one can be this one. This is another central angle. So let me call it beta. Sorry, an inscribed angle. I can choose this one. And if you want, I can connect it to this one. I can, for example, call it gamma. All these angles that you see, they are inscribed angles. Yes, questions? You had questions, Omar?
Yes, I was gonna say, I was gonna guess what inscribed meant.
Yeah, okay. Oh, I told you, sorry. Yes.
You re-explain subtended.
Subtended is a word. It means opposite here. If you don't like the word, it means that if I ask you which arc is opposite to alpha, you will show me this arc. We say that this arc is subtended by alpha, or alpha subtends this arc. If I ask you which arc subtends gamma, it means that which arc is opposite to gamma. Again, same AB. But here, of course, which arc is subtended by beta, C, for example. That. Now, that's just the name. It's not important. But what is important is this very interesting property that we want to discover today. So even if I don't know what alpha and gamma are, I am sure that they are equal in size. Okay, so we want to consider these things. That's a theorem. We want to prove that if I have any two inscribed angle opposite to the same arc, the sizes are the same. So if, for example, this is 30 degrees, this is definitely 30 degrees. It is not trivial. We want to prove this. Okay? And another interesting property is a relation between a central angle and an inscribed angle. Okay? That there is also a very nice relation between them. So we want to prove these two. For example, if I give you a central angle, any angle that you like, for example, let me call it alpha, and then I draw an inscribed angle, but not any random inscribed angle. An inscribed angle, this vertex can be anywhere, but I demand that it subtends the same arc as the central angle subtends. What do I mean by that? I mean, for example, here and here. Okay? If this angle is alpha, let me call this angle beta. I want you to understand the difference. This angle is central, this angle is inscribed. But what they have in common, they have the same arc, opposite to them. If this happens, the size of the central angle and the size of the inscribed angle are very nicely related. This one is exactly 2 times larger than this one. Okay? We don't know why yet. I just want to tell you the results, but then we go through understanding why this is the case. Okay. So this is something I want to show. What do I want to show? I want to show that if I have two angles, one central, one inscribed, but both of them subtend the same arc, the size of the central one is exactly, not approximately, it's exactly 2 times larger than the size of the inscribed one. This is something that we want to show, yes.
In a central angle, the tip is always in the middle of the circle, right?
Middle means central, center. I don't know what, in Swedish they said midpoint, but in English we say center, yes? So it is, yes, this one is always center. And the arms are radii. But here, the vertex is somewhere on the circle, yes? And the arms are chords, not radii, yes?
Can radius be called chord as well? Or no?
What?
Can radius?
No. Radius cannot be chord because chord has 2 sides on the circle. Has 2 points on the circle. The radius has 1 point on the circle, 1 point on the center. Yes? That's not correct. Okay, let us try to understand this. Yes?
So is 2D equals to the...
No, we haven't proven that yet. We want to prove it. I just gave you the message, okay, and then I want you to understand what is the point. We want to understand why this is the case. Yes. Yeah, I know. Yes, but I think, yeah, we can change. Okay, so back to the lesson. Let us consider some cases that I want to convince you. Let us try to do this. Let me take this to be center and draw a diameter, and then draw this line here, okay? And then let me also draw this line. Okay, so let us try to test your understanding. This is the center, and let me call this A and B. This angle, I want to call it angle X. This angle, I want to call it angle Y. If I ask you what is the name of the angle X, let us just review what we learned. What is the name of angle X? It's a central angle. Why? Because the vertex is the center and the arms are radii. And then if what type of angle is Y? Inscribed. Why? Because the vertex is on the circle and this arm is a chord. This arm is a diameter, but every diameter is a chord. Yes, not every radius is a chord. This diameter is a chord. So that is an inscribed angle. We want to show that, it is very simple. I want to show that the size of X is 2 times larger than the size of Y. This is very simple. Of course, this is one special case. That is a little bit harder case. I will come back to it. But that is one special case. Can you tell me why this is correct? It is not hard to understand why this is correct. You can come up with the answer yourself. Why this X that you see here is 2 times larger than this Y?
X is closer to the 2 points.
No, why it is exactly 2 times? You might feel that, yes, this is bigger, okay? But yes, you can say that because this is closer here, it is wider, so it is larger. I agree with this intuition a little
Does
bit.
that have to do with the fact that Y is a diameter, I mean a radius away from X?
So this is R. I agree. What is this length? This is R. There is another length which is also R. Which one is that?
C to A.
C to A is also R. Okay? So now I ask your opinion about this triangle. You might have forgotten this English word. You can say the Swedish word. What is the name of this triangle? You see this leg and that are exactly the same size. If you have what? Yeah, it is isosceles in English. It's an isosceles triangle. Yes? Okay, if this is an isosceles triangle, let me ask your opinion about the size of this angle. What is the size of this angle?
Same as Y.
Same as Y, exactly. Because this is, if you have a isosceles triangle, if this size is equal to that size, if I call this alpha, I am allowed to call this one alpha as well. Yes? If I have a triangle with 2 sides equal, the angles up close to those sides are also equal. So now if this triangle is an isosceles triangle, which it is, because this is R, this is R, so if this angle you say it is Y, I am allowed to call this angle as well Y. Yes? Yes or no?
Yes.
Okay. But now let me call this angle Z, which I don't know. But you remember Math 1C, we learned something about the sum of the angles in a triangle. What is that? So Y plus Z plus another Y is supposed to be 180. This we learned. And then Y plus Y is what? 2Y. And then plus Z. What is Z? Z has some relation with X. What is that relation?
Z plus X is 180.
Yes. So it means that if I want, so Z plus X is 180. So if I ask you to write something for Z, you move X to the other side. So Z becomes what? 180 minus X. So here, Y plus Y, 2Y. But instead of Z, I am allowed to write 180 minus X. Yes? So you see, Y plus Y is 2Y. Instead of Z, as you told me, I wrote 180 minus X. And then after that, I have equality. And after equality, I have 180. Now you can see what is happening. I move 180 and minus X to the other side. So I leave 2Y here. I have 180 there. I move this 180 to the other side. It becomes minus 180. I move minus X to the other side. It becomes plus X. And then what happens? This one and that one are gone. So 2Y becomes equal to X. So this is always the case, that the size of this is 2 times larger than that one. But it does not cover the whole scenario. This is not exactly the picture that I drew there for you, yes? But we want to say that no, even for that case, this rule is true. Okay, so let's try to understand. Is that any question here?
No.
Okay, but now let us try to make it more interesting. So let us try to formulate the problem in this way. I draw another picture. So let us say that I have this circle here. Let me draw one central angle here. And then let me draw one inscribed angle, but subtending the same arc. So for example, let me choose the point here. Yes. Okay, so let me call this one as before Y. Let me call this one X. Okay? And this is the center. Let us review things again. And if I ask you what type of angle is X, what do you say? It is central. What type of angle is Y? It's inscribed. We want to prove the same thing again, because if I ask you what is the arc subtended by X, you will show me this black curve. If I ask you what is the arc subtended by Y, you show me the same black curve. So it means that it is an inscribed angle, this is a central angle, but both of them are subtending the same arc. This is important, not just random ones. We want to prove that, again, the size of this one is still 2 times larger than the size of that one. Okay, so how we can convince ourselves for this one? It is not as trivial as the previous one, but still it is true. We want to explore that, yes?
Are we allowed to draw a chord?
Yes, so you are allowed to draw anything on, yes, yes, what do you want me to do?
On the
I can name them so that you can talk about the names to me, okay? A, B, C, for example. Now C is reserved here, so if you don't mind, let me call it D. Okay, chord. Okay, so what do you think I can do here? Yes, Ahmed is right. We have to draw a line somehow.
From A to B.
From A to B. Is it helpful? Let us check. I don't know. So you are telling me that connect these two. Okay, if I connect them, is there any way that you can solve the problem?
There is a better one.
Okay, so Ahmed, you don't defend yourself?
Oh no, I'm just trying.
Okay, okay. So what do you say?
From Y to C
Don't say y, d.
or D.
What? Yes.
D
If
to
I draw this one to that one, okay, what happens?
it becomes isosceles.
This which one becomes isosceles? Name it.
Both of them.
Yes, this one and that one. But be careful, they are not of the same sizes. Yes? So you cannot say that when I draw that, this part is y over 2, that part is y over 2. There is no guarantee for that. If you have this angle, if this line happens to be exactly in the middle, yes, I agree. This becomes y over 2, this becomes y over 2, but there is no guarantee. Might be that line is passing a little bit to the left, then this part is smaller than y over 2, this part is bigger than y over 2. Or it might happen that it passes a little bit to the right, then this angle becomes bigger than y over 2, that angle. So you cannot say that this is y over 2, this is y over 2. Yes? But you know that the sums are what? Yes. I agree with you. This is a good thing to do. Because instead of y, if you don't mind, let me write alpha and let me write here beta. One thing I don't know alpha, I don't know beta, but I know what is alpha plus beta. What is that?
Y.
It is the old y that we had. So remember that. I don't want to write y to not mess it up. But you understand that that was named alpha. I removed it in my head. I had two parts, alpha and beta. I don't know if alpha and beta are equal, but I know something. The sum is y. Okay, what should I do? So then what? If that is alpha, can you tell me yourself what is this now?
Also alpha.
Also alpha, do you agree? Because now this triangle that you see here is an isosceles triangle. Why? Because the length from here to here is one radius. The length from here to here is also one radius. So these two lengths are equal. So if I call this alpha, I am allowed to call this one alpha 2. Yes? With the same idea, if I call this beta, am I allowed to call this beta as well? Yes, because for the same reason, this length is one radius. This length is also one radius. So the right-hand side triangle is also an isosceles triangle. Yeah, it is very good. Then what? You are very close, I would say. If I were you, I wouldn't stop my line there. I preferred to continue this red line that you told me to draw until it goes here. Let me call this E. Yes? Then this x is also split into two parts. Not necessarily equal parts, but it's also split into two parts. So let me clean it and let me write, for example, here theta as another Greek letter and rho. I don't know what theta is, I don't know what rho is, but I know what theta plus rho is x. Now everything is very simple. I hope you understand that. Yes? Can you tell me what is this theta according to this picture? Can you compare the left-hand side of this picture with the picture you have here? Yes? Yes. Y, here alpha is playing the role of this y, and theta is playing the role of this x. But in this picture, I proved that x is 2 times larger than y. So then what does it mean here? Can you tell me? It means theta, which is the counterpart of x in this picture, is 2 times larger than what? Alpha. Yes? But then don't look at the left picture, look at the right picture. The right picture is the same picture, yes, but reflected here. But the rules are the same. So what can I write for rho? What is rho? Rho is 2 beta. Yes? And now start adding them side by side. It becomes theta plus rho is equal to 2 alpha plus 2 beta. But 2 alpha plus 2 beta, I can factor 2 out. It becomes alpha plus beta. Yes? So what is theta plus rho? It is x equals to 2. What is alpha plus beta? It's y. So still it is correct. So you see, the first one is important. You start with this picture to convince yourself that if one line is diameter, this is 2 times larger than that one. And then, as Omar mentioned, it was a good trick to do the same thing here. By drawing this diameter, if you are a little bit smart, to draw this diameter, then you understand that you have 2 versions of this problem. You don't need to start everything from scratch. You can use the result here and then convince them. Is that right?
Yes.
But of course, that is also not the whole story. Might be the mysterious one is still left there. It's a little bit harder. Okay? So let us go back here and convince ourselves that this is also the case, and then we are done for all possible cases. Why it is done? Because here we considered the black, the central angle within the inscribed angle, and then here we considered one common arm for both of them, and here we are considering that the inscribed circle angle is completely outside the central angle, but we still want to prove the same thing. It's a little bit harder to understand what to do here, but then it is interesting to see that this is also working. For example, can you convince me that this is indeed the case? We want to prove the same thing. I want to prove that in this picture again, the size of alpha is 2 times sine beta, but I want to repeat again everything. What is the name of alpha? What type of angle is that? Central. Why? Because the vertex is the center and the arms are radii. What type of angle is beta? Is inscribed. Why? Because the vertex is on the circle and the arms are chords. I want to show that again, and then it is important, the most important part I missed, sorry. What is the most important part? These two should subtend the same arc, not different arcs. Yes? If I have different arcs, for example here, I cannot say that alpha is 2 times beta or whatever. No, because, sorry, I cannot, for example, draw the central angle here. I cannot say that this angle is 2 times this one. This is correct because they are subtending the same arc, but I cannot say that this one is 2 times larger than that one because this one is subtending this arc, this one is subtending the other arc, another arc. It is important that they subtend the same arc. In that case, the size of the central one, no matter how you draw it, is 2 times larger than the size of the inscribed one. Okay, if we can do this one as well, then we are convinced that in all cases this is working. But how can I convince myself in this case as well? You have to draw a line again. But which line do you think is useful here?
I don't know how to do the rest.
Let me give the name for you so that if you want to name them, you can call them A, B, C is already reserved here, D. Yes. Do you have any opinion?
Wait, is that D, right?
Yes. Yeah.
From D to C.
Okay, so let us see. Is there any? Okay, no worries. Even I don't know. We draw and see what happens. So you are saying that I draw a line from here to here and then continue, okay? So if you don't mind, let me make it dotted. It means that I am adding something to my picture, okay? Okay, so do you think it is helpful?
I don't know. Oh yes. Oh.
Hmm?
Din annan ark där borta. Åt vänster.
Yeah, think a little bit. This one.
Yes, I'm working on it. Yes,
Okay.
and I did the same.
Yes.
I named after you drew the diameter
Yes.
on the left. I named that one Z.
Z.
No, the little next to the X, left of the X.
Where is X?
Yeah, X in the middle.
So your X is in the middle. Yes?
No, down. Like the angle X.
It's not alpha.
It's alpha, okay.
Left of it, I named the angle, new created angle with
Yes,
diameter.
this one?
No, left. Angle, yes.
This
I created
angle.
yes, exactly. That one Z,
Z.
and then on the right, that one Y, and XYZ becomes 180.
Yes.
And then between alpha and beta, there's like an X symbol, and
Yes, here.
yes, and I named like top and bottom D and left and right A, and that makes 360.
This D, A, yes.
And I drew a chord between.
So you're making it so complicated.
Uh-huh.
Yeah, but it doesn't matter if you can manage to do it. Could you manage it?
No, I'm trying to.
Okay, so you are sending me to the hell.
I want you to help.
Okay. No, I thought that you solved that. Okay. If you haven't solved that, you still work on it. Okay, that's a different problem. Okay, let me call this point E if you, in case you want to name it. Okay, so if you want, I can call this X, I can call this Y. I don't know if they are necessary. Let us not mess it up. We just name them if we really need them. But you have to have a strategy to find the relation between alpha and beta. I want you to think a little bit yourself. Think a lot of names here because you understand what is the goal. The goal is to use the isosceles triangle idea. Because you have a little bit of experience from two simple cases. In both cases, we use the idea of an isosceles triangle. So don't give up unless there is a good reason for it to give up. So I don't know where is my green pen. Let's see. I don't know, for example, so this is one of your isosceles triangles you can imagine. I don't know, there is another isosceles triangle you can imagine, the bigger one. So let me call the center C. That is also the bigger one. Do you think that they are enough to consider what you need? Yes? Okay, so think about it. For example, let us concentrate on this. Do you agree this is an isosceles triangle? Why? Because this leg has length R. This leg has also length R. So if I call this gamma, am I allowed to call this gamma as well? Yes. It is a better one because you see I am not bringing two names in, I am bringing one name in. Usually in geometry this is much better to do. Don't increase, so you see Ahmad say A, B, B. That's also working, but that would be two letters. But here we have one. Okay. Any other scenario? Is there any other one that you can see? It's very simple, you see. So think about this angle. Can you give this angle a name? Of course you can give it Z, X, or whatever. But tell me, what can I write for this one? Gamma plus beta. Yes, do you agree? Because this triangle is also what? Isosceles. Why? Because this is a still R. This one is a still the radius. So the length here and the length here are both equal to the radius. So they are equal. And if I ask you, what is this angle? You will tell me it is alpha plus beta. So then what does it mean for this angle? Beta plus gamma. So that's also correct. Okay, try to finish the problem. But don't lose your goal. Your goal is to find a connection between alpha and beta. We haven't found that yet. But I don't think it is hard to find it out. Could you? You are waiting for me or you are thinking?
And I established that alpha is 2 gamma minus 180.
Okay, so what you are doing, you are considering this triangle,
Yeah.
and then if I call this x, x plus this angle,
Yeah.
which is beta plus gamma,
Mhm.
plus this angle, which is again beta plus gamma, is 180.
Yeah. So then I wrote like basic. I wrote 2 beta plus 2 gamma minus 180, and then I proved that like alpha is 2 gamma minus 180. Like
So this is one I agree with you.
Yeah, but
Then let us write something else in this bigger one.
Oh yeah.
So
okay,
then
no,
it becomes
I did
alpha
I did a mistake.
plus x plus gamma, yes,
Yeah.
is again what?
180.
180.
Yeah.
And this is 180, this is also 180, so they have to be equal. So this means that x plus beta plus gamma plus beta plus gamma is equal to what? Alpha plus x plus gamma plus gamma. But then you see this gamma move to the other side will cancel this gamma. This gamma move to the other side, cancel this gamma. X from this side move to the other side, cancel that x. And then what is left?
2 beta and
2 beta. What is left on the right? Alpha.
Yeah.
And that was correct. Okay, I'm not saying that this is the only way. Might be it's a little bit more complicated than usual. You can find a little bit simpler way. But I hope that you understand that in all possible cases, if I have one inscribed angle and if I have one central angle, they are subtending the same arc. The size of which one is 2 times of the other one? The size of the... Okay, so I hope that... So this is something for the people who want to understand the reasons. But what I expect you to in the exam is to know this rule and to be able to use it to solve problems. So if I want to summarize all what we did, you can momentarily forget about if you don't like this, but you need to remember this. If I have two angles in one circle, one of them inscribed, the other one central, and they are subtending the same arc, the size of the central one is 2 times larger than the size of the inscribed one. That is the message of what we have done so far. Is that clear?
Yes.
Yes or no?
Yes.
Okay. So let me ask you one question if you understood it correctly. I draw a circle here for you. Yes? And then I draw a diameter, any diameter that you like. And then I pick up a random point, a complete random point on the circle. And then what I do, I take these points of the diameter and connect it here. Okay? Is there something I can say about this angle? Something completely concrete and definite. Or you might say that no, it depends to where I choose the random point. If I choose the random point here, this angle might be different. If I choose the angle here, you might say that this angle might be different. Can I say something about all these question mark angles? First of all, do you see that they have to be all equal? Let us understand that because that's very important. You see, if I give you this scenario, I draw this angle. This is what type of angle? Inscribed. But these 2 points, I take them and connect them now here. Then I get another angle beta. Can you see why this alpha and beta are equal? Why they should be equal? Be careful. This is inscribed. That is also inscribed. But they are subtending the same arc. In the case that one of them is central, one of them is inscribed, the central is 2 times larger. But here I am telling you these two are the same size. Alpha is equal to beta. Why is that? You don't need to go through the long process. This is something that you need to know. If I have two inscribed angles opposite to the same arc, the sizes are exactly equal. Why?
Because the central angle is supposed to be double more than
Exactly. So because I intentionally wanted to a little bit make it harder for yourselves, let us say that this is center. I connect this center to here and here. Then I generate an angle here, gamma. Yes? This gamma is a central angle. And this angle is an inscribed angle. But the central one subtends this arc. The inscribed one also subtends the same arc. So what is the relation between alpha and gamma? Gamma is 2 times larger than alpha. Yes? This set it aside. Now forget about alpha, try to compare all gamma and beta. According to the same idea, what is the relation between beta and gamma? Because they are also subtending the same arc. One of them is central, one of them is inscribed. So what can I say between gamma and beta? Gamma is again 2 times beta. But now gamma and gamma are the same. So it means that I have to agree that 2 alpha is equal to 2 beta. And if 2 alpha is equal to the beta, and then it means that alpha is equal to beta. In the exam, you don't need to give reasons for that. You can use them. But you need to understand how to use them. If you have 2 or more, I mean, for example, this picture is good to have in mind. If I have this picture, I don't know, I take these 2 points and connect it here. I take these 2 points and connect it, for example, here in this extreme. If this angle is alpha, this angle is beta, this angle is gamma, what can I say about alpha, beta, and gamma? They are equal. Okay? Because all of them are inscribed opposite to the same arc. If that is the case, all of them inscribed opposite to the same arc, the sizes are the same. If someone asks you why, you should be able to explain. How do you explain? You would say that I take the center, and then I take these 2 points and connect it to the center. Then this makes me an angle theta. Theta is 2 times alpha because of central inscribed angle. Theta is 2 times beta. Theta is 2 times gamma. If 2 times alpha, 2 times beta, 2 times gamma are all equal to theta, then it means alpha, beta, and gamma have to be equal themselves. So this is, I want you to understand, not just to memorize. But what is important for the exam is to be able to use the rule. Okay? So now let us go back to this question. I hope that now at least you understand that all question marks are equal. Can you tell me why? Why the size of this question mark and that question mark and that question mark are all the same? Do you remember? This was diameter. It is passing through the center. Why these question marks? Let me call them alpha, beta, and gamma again. Do you see why alpha, beta, and gamma are equal? Why? All of them are what type of angles? Inscribed. They are opposite to the same arc. What is that arc? This arc. All of them are inscribed opposite to this big arc, but that's an arc. So it means that the size of all these angles are the same. Alpha, beta, and gamma are the same. Is that understandable? But in this case, I can say something more. Not only they are equal, but I exactly know what the value is. Yes? What? How is that possible that alpha is 360? Yes? Refer to your brain a little bit. Yes? Is that possible? No. Okay, so.
Nothing's impossible.
Yeah, of course, you're right. But then, what is that size? No, don't say it. My picture is awful. Don't rely on my picture. Try to understand the logic. So I hope that everyone understands the connection of my explanation here and the connection here. They are all inscribed. They are all inscribed angles opposite to the same arc. So the sizes according to this should be all the same. But here, if you ask me, Babak, do you know the sizes of these angles? No. I cannot say anything, but I know that the sizes are equal. But in this case, I am saying that not only they are equal, but I know exactly the size.
So 90
Can you define? Yes, that's 90. And why that is 90?
because the central angle there is 180.
80. Yes, where is the central angle? It's a little bit hidden. This is a central angle. And everyone knows the size of the central angle. What is the size of the central angle? It's here, 180. Why? Because it's a diameter. Okay, so this is a central angle subtending this arc, and these are inscribed angles subtending the same arc. According to central inscribed angle, the size of the central one should be what? 2 times larger than the size of the inscribed one. If the size of the central one is 180, then the size of the inscribed one should be 90. Is that right? So that is also an. So if this happens in the exam, you can use it. How should you refer it in the exam? You say that inscribed angle opposite to a diameter. So remember, an inscribed angle opposite to a diameter is always 90 degrees. It doesn't matter if the circle is big or small or whatever. And where the diameter is, it doesn't matter. So for example, let me just try to draw another picture. So I just draw another random one. This is the center. I draw a random diameter. And then I pick a random point, doesn't matter on the right or on the left, and I connect it to the end of the diameter. Then what is this angle? What is that angle? What is that angle? What?
90.
90.
Sorry.
Yes, it is 90, yes? Why? Because it is an inscribed angle opposite to the diameter. If you want to use it in the exam, you don't need to prove it for me every time. You need to tell me that, okay, that angle is an inscribed angle opposite to a diameter. So it is 90 degrees. Yes? Is that understandable? Okay. Now, there is one interesting question here that is also in the book. I want you to discover it yourself. What I do, I draw a circle here now, any circle, but then I try to draw any quadrilateral. In a way, quadrilateral is a shape with 4 sides, so that the vertices are all on the circle. Okay? So for example, I take a point, I take another point, I take another point, and I take another point, randomly, okay? And then I draw my quadrilateral. If you want the name is not in the book, but if you want the English name, this is called a cyclic quadrilateral. Quadrilateral, yes? Forget about the name. Okay, what I want to tell you is that this is alpha. Okay? By the way, let us review something from Math 1C. If this is alpha, this is beta, this is gamma, and this is theta. We learned something about alpha plus beta plus gamma plus theta. Not only in the circle, in any quadrilateral, we learned something about the sum. What was that? 360 degrees. Do you remember more or less why? Because every quadrilateral can be partitioned into 2 triangles. And for each triangle, the sum is 180. So for the whole, it would be 360 degrees. But if that quadrilateral is like this within a circle with the vertices on the circle, we can say something interesting. Alpha, I don't know what the size is. Beta, I don't know what the size is. But I know something about alpha plus beta. I want you to tell me what that number is and why. It doesn't matter how I draw. The opposite ones, the sum of the opposite ones is always one number. If my quadrilateral lies on the circle. If it is not, no, I cannot say anything more. But if it is lying on the circle, I can say alpha plus beta plus gamma plus theta is still 360 degrees. But in this case, alpha plus beta is one particular number, always. And what that number is? Okay, can you defend that? That's correct. This becomes 180. Okay, can you tell me if this is the case, what is left, what is the share for the sum of these two then? The same, because the sum should be 360 degrees. If you can defend this one, it is automatically concluded. Because the sum of all of them is supposed to be 360 degrees. If you can defend this, why this is true, then of course this will follow immediately. Can you defend that?
I put a point in the middle.
Exactly, thank you. We find the center. There is somewhere in the center is somewhere. And then what do you do?
Draw a line from.
Let me call them. Yes?
From A to C.
A to C is not good if you want to prove this. Because if I draw A to C, I am splitting alpha into two parts. I need the whole
Oh,
alpha.
I mean from D.
Yes, so I draw this line and I draw that line. Do you agree? Okay, now my question for you is this. If you don't mind, let me call this angle X. Okay, what is the name of this angle in general? What type of angle is X? What type of angle is that? Central. Why? Because the vertex is the center and the legs are radii. So, what is the name of this angle? What type of angle alpha is? What type of that? What? It's inscribed. Because the vertex is on the circle and the legs are chords. But do you think that alpha and X are subtending the same arc? Yes or no?
Yeah.
Yes, because this X is subtending this arc. Yes? This is one leg, this is another leg. So this X is subtending this arc. What arc is being subtended by alpha? Do you see that? It's exactly the same arc. Yes? So, one of them central, one of them inscribed, subtending the same arc. What is the conclusion between the size of X and the size of alpha? Size of X is what? 2 times size of alpha. Yes or no?
Yes.
Okay. Now, let us visualize the problem from a different perspective. If I call this Y, what type of angle is Y? Central. Yes? Because the vertex is the center and the legs are radii. What type of angle is beta? Inscribed. Why? Because the vertex is on the circle and the legs are chords. But can I say beta and Y both subtend the same arc?
Yeah.
Yes. Which arc? This green arc. Do you agree?
Yeah.
So the arc opposite to Y is this green part. The arc opposite to beta is also the same thing. So I have one central angle, one inscribed angle, subtending the same arc. What can I conclude about the sizes? Y is equal to what? 2 beta. Yes? But my question was something related to alpha plus beta. I want to know something about alpha plus beta. So it motivates me to add them up. X plus Y becomes equal to alpha plus 2 beta. I can factor a 2 out. Yes, it becomes alpha plus beta. Agree or not?
Yes.
Do I know something about X? No. Do I know something about Y? No. But do I know something about X plus Y? 360 degrees. Yes? So it becomes 360 degrees is equal to alpha plus beta. So I am looking for alpha plus beta. So what's alpha plus beta? 180 degrees. So this is also in your book. I want you to understand that. So if I have a random quadrilateral, be careful. If I have a random quadrilateral, if this is alpha, if this is beta, this is gamma, this is theta, what can I write for this random one? Only one thing. Alpha plus beta plus gamma plus theta is what? Nothing more. I cannot conclude that alpha plus beta is 180, gamma plus theta is also, theta plus gamma is also 180. No, this is the only thing I can write. But if it happens that a circle goes around that in a way that all vertices are on the circle, then not only alpha plus beta plus gamma plus theta is 360 degrees, but I can say something more. I can say the sum of the opposite ones are individually equal to 180, which I couldn't say in Math 1C if I don't know if it is on the circle. Okay, is that clear? Okay. So that's also something I want you to know. So let me see if there is something missing from the lesson that I haven't done. So you have to train your eyes to catch this pattern. Okay, and there are a lot of exercises in the book. So if you don't mind, let us try to show and solve some of them. Okay. So let me see if it is being recorded or not. No, I don't know. Yes, it is good. Okay, so here, determine these angles. For example, everyone tell me, what is this angle? What is the size of angle X? 57. Yes? Then what is the reason? Both of them are inscribed opposite to the same arc. So that's it. Can you tell me what is V here? What is the size of V? Why? Because one of them is inscribed, the other one is central. The central is 2 times larger than the inscribed. So if the bigger one is 140 degrees, 14 degrees, then the other one will be half of it, which is 57 degrees. Is that understandable? Okay, so for example, can you tell me what is X, Y, Z in this picture? All of them are 55. Because those three are inscribed ones, opposite to the same arc, and this arc is subtended by a central angle of size 110. So all those inscribed ones should be half of it. Understandable by everyone? Everyone understands that? So it is 55. Yes? Okay, so for example, in this picture, what is the size of U? What is the size of V and U? Do you see that? I can make it a little bit bigger. So this one. Which one is 40? Both of them. But V is 40 based on today's lesson. This one is inscribed. This one is central. The central is 2 times larger, so the inscribed is 40. But why U is 40? It has nothing to do with this lesson. It is something related to Math 1C lesson. Why U is also 40? Because this triangle that you see here is an isosceles triangle. Why? Because both of them has the size of a radius. Is that right? Okay, so this is, you see, it is not hard at this level. Okay, so let us make it a little bit more interesting. Okay, so can you tell me, I want to test your understanding. So can you tell me immediately, this point is the center, you know, this point that you see, you might not see, I don't know, from that distance. This is a center, the center. What is U? 90. What do you write in the exam? If I ask you why? You say that inscribe opposite to a diameter. So this is inscribed opposite to a diameter. So what is the size of V then? 90. Again, for the same reason. Inscribe opposite to the diameter. Yes? Okay, a little bit more interesting question is this one. Yes, I will try to see if it works. Yes, I think it works. So here. This angle is 24. This angle is 53. And then they have put a point here. Of course, they mean that is the center. Might be it is necessary. We don't know yet. And they are asking about U, V, and U. And I would say that the point, the center is not necessary at all. It's like a butterfly. So remember this shape of a butterfly in different directions. Okay? So can you tell me, everyone concentrate on V first. Can you tell me what is V? 24. Why is that? Because if I ask you what is this angle, you will tell me it is inscribed. If I ask you what is this angle, you will tell me that is also inscribed. But are they subtending the same arc? Yes, this arc that you see here, let me change it. This arc that you see here is subtended by this one and that one. So they have the same sizes. And what is the size of U? For the same reason, it is also 53. Is that right? Okay. So now let us see if we have a little bit more interesting questions than this. Okay, so I want to wait for you, okay, to try to find this and then I will ask you. Okay, question 425. 42505. Okay, so here they are asking you about determining the angle P and the angle Q. Of course, one of them is mentioned to be 3A, one of them is mentioned to be 7A. I don't know what it has to do with this lesson. I don't understand that. It's a Math 1C lesson, to be honest. So what is the size of angle P and what is the size of angle Q, if that is Q? I don't know where Q is. Yeah, Q is here. Yes, that's the center. So what is that? And they have mentioned you that this angle is 90. So I don't know what they want to do here. What they want to do, you know? So you shouldn't get confused because they have drawn a circle for you. We don't care about that. What we care is that, they have given you this. They have given you this angle is 90. Okay? And they have given you that this angle is 7A and 3A. And they want you to tell me what is this angle and what is this angle. So in order to answer this question, you need to know the unknown A. But how can I find the unknown A? It has nothing to do with today's lesson. How can I find that angle A? Yes, because if this is 90, this one is also 90. And then I know that in any triangle, the sum of the angles should be 180. So I move this to the other side and I add them up. It becomes 10A is equal to 90 degrees. I am looking for A, so A becomes 9 degrees. But A is 9 degrees. They want you to find angle P. So what is angle P? Angle P is 3 times A. So it is 27 degrees. What is angle Q? Angle Q is 7 times A, which is 63. I don't know. This has nothing to do with this. Okay, but this is a little bit more interesting question. Question number 4206. Yes? 4206. I want to wait for you. Okay, everyone solve this problem individually. Yes? I can make it a little bit bigger and then move it a little bit here. Okay, I want to wait for you to do this problem. It's a little bit ambiguous. You see, this point is not clear. Is it on this line or not? Don't consider it on the line. Yeah, I don't know why they have put the dot there. The reason is clear. They want to confuse you. But why, I don't know. This one is easy. Do the part B. This is not ambiguous at all. This is a good question, E-level question for the exam. Part B, solve it. Can you tell me what is good for this problem? It's on the board still. No? This one. I told you that if you have a quadrilateral without any circles, you cannot say something more except this. But if you know that the vertices on one given circle, you can say that the sum of opposite ones are 180. Okay? So if I go back to this, if I go back here, this one, what else? So let me change this. This one plus this one is supposed to be 180. Okay, so I'll go to the board. What is the angle? One of them is 4x, the other one is 8x. It is supposed to be 180. This becomes 12x is 180. I divide everything by 12 to get x, so x becomes 15 degrees. 180 divided by 12 is 15. Yes? But I want to find u and v. Where is v, by the way? In this picture, we don't have any v. We have only u. I also know something else. I know that this is I know that this one plus u should be again what? 180, yes? So it becomes 7x, u plus 7x is 180. But I found x from the previous calculation, so I put it there. 7 times 15 degrees is what? 105. Yes, it becomes 180. Then I am looking for u, so u becomes 180 minus 105 becomes 75 degrees. Yes. So we were able to find u very easily. So you see, this is E-level question, not hard. You see, even for this case, it doesn't matter if this point is given to you or not. Forget about this point. You have a quadrilateral. You see that the vertices are where? Yes, the vertices are on a circle. So regardless of this fact that if this is the center, if the center lies on this line or not, we don't care. We have a quadrilateral. The vertices of the quadrilateral is on a circle. So what can we conclude? We can conclude 63 plus V is 180. So what is the share for V? 117. And then we also know that U plus 121 should also be again 180. So regardless of this is a center or where the center is, we don't care. Even in this case, we don't care. Okay, so U plus 121 is also 180. So what is the share for U? 59. That's correct. Okay. So we stop the lesson here, but before we leave, I check the attendance.